everyone, this is Jay, your instructor for computer networks. And in this session, we are going to discuss the difference between the pure ALOHA and the slotted ALOHA. So let's start. This pure ALOHA and the slotted ALOHA are the part of the random access protocol. So what is the random access protocol? In the random access protocol, we will see that when there is a collision in network, they will wait for some random amount of time. You are going to discover that in the random access protocol, there is a high possibility that the sent data will be part of the collision. So there are some steps for the random access protocol, and let's see that first. So in the random access protocol, all the stations have same priority. There is nothing like master or slave. And in the random access protocol, there is no fixed time for sending data. Any station can send data at any time they want. There is no slot. So they are flexible to send data at their own time. And in the random access protocol, the third point is that there is no fixed sequence. It means that there is no queue. So when there is no queue, any station can send data at any time because they does not have to wait for their previous sender to complete its transmission, right? So after that, the next point in the random access protocol is that two or more stations are sending data at the same time, it will create collision. So it is very obvious, right? Because there is no priority, there is no fixed sequence, and there is no queue. There is a high possibility that channel all the devices share will be the part of the collision, because there is a high possibility that two or more devices are sending data at the same time. So when they are sending data at the same time, all the data that are sent by those devices will be collided together, and it will create noise, right? It will create junk in the channel, and this noise, if received by receiver, it will not be able to understand that what is its data, like what is that data, because it is nothing but the junk data. All the signals are changed drastically. The random access protocol, we will see that how to detect the collision, and we will also see that how to record from the collision, like how the station know if station has sent the message, how he or she knows that its own packet is the part of the collision, and what it has to do when there is a collision in network. So these are the point that we are going to see. So there are many types of the random access protocol. The first type of the random access protocol is the ALOHA. It is further divided into the pure ALOHA and the slotted ALOHA. The second type of the random access protocol is the carrier sense multiple access, and it is also divided into two types. The first type is the carrier sense multiple access with collision detection, and the carrier sense multiple access with collision avoidance. So first one is also known as CSMS CD, and the second one is the CSMS CA. In the ALOHA methods, we will see that the system is totally dependent on the acknowledgement. So after sending packet, the sender will wait for the acknowledgement from the receiver. If the acknowledgement is not received, the sender will going to assume that its packet is a part of the collision, so station will retransmit the packet after some time. In the carrier sense multiple access, there is no acknowledgement. So how the station knows that its packet is delivered or not? So in the carrier sense multiple access, the before sending any packet, the sender will check the channel. If the channel is free or it is idle, there is no transmission, then it will send the packet and it will assume that there is no collision. We are going to see that we will see that in more detail when we'll discuss the CSMA method. In this session, we are going to see the pure ALOHA and the slotted ALOHA. So in the pure ALOHA, any station can transmit data at any time they want. There is no time limit, and after sending the packet, the sender will wait for some fixed amount of time. Why sender is waiting for some fixed amount of time? because sender is waiting for the acknowledgement. For example, after sending packet, sender will wait for 10 seconds. So within those 10 seconds, the sender should receive the acknowledgement. Sender is supposed to receive acknowledgement. If sender has not received acknowledgement, it means that there is some problem in the channel, and sender is going to assume that there is a collision in network. So it will wait for some time, and after waiting for some time, it will send the packet again. And if acknowledgement is not received, then there is a collision, right? So this is the figure of the pure ALOHA. You can see that there are 6 devices, A, B, C, D, E, and F. And those devices are sending packet in the shared channel. The channel is common between these all devices. You can see that the first packet which is sent by the device A is sent successfully. After some time, when A has completed its transmission, B has begun its transmission and B has sent its data. After some time, the device E has transmitted its packet. But when device E is at halfway of its transmission, the C has begun its transmission. So you can see that the C and E packets are the part of the collision. Now these packets are the part of the collision. The receiver of C and E will receive nothing but the junk data. So all the data is received by those receiver are the junk, because those data are the part, or those data has gone through the collision. So when there is a collision and when the receiver receives junk data, receiver will not provide any acknowledgement. So if receiver doesn't provide any acknowledgement in the stimulated amount of time, the sender will going to assume that okay, there is some problem, so there is a collision, so sender will send the data again. Now notice, sender cannot send data again as soon as it knows that there is a collision, because if it send data as soon as it knows that there is a collision, there will be high chance that again there will be collision. So instead, sender will wait for some random amount of time, which is also known as back of time. So in the back of time, the sender will wait for some random amount of time. For example, C will wait for 5 seconds and D will wait for 10 seconds. And after waiting for random amount of time, they will send their packet again. Because there is a low possibility that the back of time of those devices will be same, the chances of the collision will be less. The second type is this slotted ALOHA. Now what is slotted ALOHA? The only difference between the pure ALOHA and the slotted ALOHA is that in the slotted ALOHA, all the time is divided into slots. So any station that wants to send data, it will send data at the starting of particular slot only. If the starting of the slot is missed, the sender is not allowed to send data in that slot. So that is the condition, that is the rule for the slotted ALOHA. The other conditions are the same, other all procedures are the same as the pure ALOHA, is that it will wait for the acknowledgement. If the acknowledgement is not received, it means that there is a collision. But because of the slot, the chances of the collision are less as compared to pure ALOHA. Let's see this figure. The 6 same devices that we saw earlier are sending data. The only difference is that they can send data at the starting of the slot. They cannot send data in the middle or any other slot other than the starting of the slot. So you can see that the device sent by the packet sent by A and C are the part of the collision, and because those packets are the part of the collision, they will wait for some back of time and they will send the packet again. So that is the slotted ALOHA. And this is it for today's session. I hope you know the difference between the pure and the slotted ALOHA. Thank you so much.